Okay, let's do an application. So, first of all, a surveyor can measure the width of a river by setting up a transit at point C on one side of the river, check out the picture, and taking a siding of point A on the other side. Refer to figure 10, you can see up here. After turning through an angle of 90 degrees at C, the surveyor walks a distance of 300 meters to point B. Using the transit at B, the angle beta is measured and found to be 25 degrees. What we're doing is trying to find the width of the river, rounded to the nearest meter. Okay, so we've got this angle. You can see they've set up our triangle. We're trying to find the width of the river to the nearest meter. All right, so we've got this angle. From this angle, we've got 300 meters adjacent, and B is opposite. And we know that the tangent ratio is the opposite over the adjacent. So let's take the tangent of 25 degrees, and that should be opposite over adjacent. Okay, now to solve that, we'll times both sides by 300. And if you just put 300 times the tangent of 25 in your calculator, make sure it's in degree mode, you should get 139.89 something else. We're going to round that off to about 139. I'm just going to do that because it does say to the nearest meter. So we're going to say about 140 meters. Then we're going to make sure that makes sense because, oh, sure enough, if this is 300, that looks to be about 140. That works. Okay, moving on. A couple of things we want to know about, and that is if we're starting at the horizontal and we're making an angle from the horizontal that moves up, the angle in between the horizontal and that line of sight is called an angle of elevation. It starts horizontal and we move up. That's elevation. On the other hand, if we start at the horizontal and we move down, then we create an angle of depression. Okay? So for the record, the angle of depression is the same as the alternate interior angle of elevation. For example, if you just look here, if this was a triangle, this angle of depression up here is the same, this angle is actually the same as this angle of elevation. So those two angles, if you remember alternate interior angles, they make the Z. All right, and then going back over here, let's do blue. This angle of elevation would be the same as if I had another one, this angle outside the triangle of depression. Okay, that might come up in a couple of your problems. So, okay, let's do another application. Here we go. Meteorologists find the height of a cloud using an instrument called a ceilometer. A ceilometer consists of a light projector that directs a vertical light beam up to the cloud base and a light detector that scans the cloud to detect the light beam. You can see the setup in the picture here. See figure 13. On December 1st, Midway Airport in Chicago, a ceilometer with a base of 300 feet was employed to find the height of the cloud cover. If the angle of elevation of the light detector is 75 degrees, what is the height? Now, we're going to round our answer to the nearest foot. Now, in this case, we've got to put the numbers into our picture. So it says a ceilometer with a base of 300 feet. So here's my base. So this is going to be 300 feet. Was employed to find the height. Okay, and the angle of elevation of the light detector right here is 75 degrees. So we look and we say we're trying to find the cloud height. We've got, again, we've got our angle over here, so we've got opposite and adjacent, and there is tangent one more time. We're not using the hypotenuse in this problem, so we don't use sine or cosine. Okay, so the tangent of 75 degrees in this picture is opposite, H, over adjacent, 300. And we'll solve this by timesing both sides by 300. Those cancel. And if you put 300 times the tangent of 75 in your calculator, with me, you should get 1119.6. I'm going to write that 19.61524. Okay. We want it to the nearest foot, so we're going to round that to 1120 feet. There we go. All right, we've got one last one. Adorning the top of the Board of the Trade building in Chicago is a statue of Ceres, the Roman goddess of wheat. From the street level, 2 observations are taken 400 feet from the center of the building. The angle of elevation to the base of the statue is 55.1 degrees, and to the top of the statue is 56.5. What is the height of the statue? Okay, so we've got 2 different triangles now. All right, so I'm going to take the statue and make it this little statue right here. I'm going to enlarge it. So to the top of the statue, to the bottom of the statue. So we've got 400 feet. And then to the bottom of the statue, so this one's 400 feet. To the bottom of the statue is the 55.1 degrees. Okay, and then to the top of the statue, that's going to be this one up here. So we've got a bigger triangle here, and that one, this guy all the way here is 56.5 degrees. And that is this whole thing. So the bigger one is, woo, that big, and the smaller one is this one. And this is what I want to know, is the height of the statue in between those two. So if I found the distance of the large one, like right here, and then I found the distance of the smaller one and subtracted them, I could get the height of the statue. Okay, so that's the plan. So we're going to get the tangent of the large one, which is we're using tangent because it's opposite over adjacent. We're not touching that hypotenuse. So the tangent of the big one, which is 56.5 degrees, that's going to be, let's call that y, big ol' y over 400. So if we times both sides by 400, cancel this. And if you put 400 times the tangent of 56.5 degrees, you will get 604.33. Okay, nearest foot, I'm going to stick with 604. All right, let's use a different color. And now let's do the smaller triangle. And we'll do the tangent of 55.1 degrees. That should be the opposite. Now that's little. Let's call this W. That's going to be W over 400. So if we times both sides by 400, and 400, if you put that in your calculator, 400 times the tangent of 55.1 degrees, you're going to get about 573. Okay, that makes sense because we're going to take the biggest one, which is 604, and we're going to subtract out the 573, and then we're going to get our answer, which is going to be 31 feet. So the statue is actually 31 feet. That's interesting. Okay, and that is the end of this video. And there we go. So we'll stop this video, and you can now go in and try your MyOpen math problems and send me your questions.